In this video, I'll be talking about interfaces, what they are, how to make them, and how to implement them. So, what are interfaces? Interfaces are a construct in Java that can allow us to affect the behavior of other classes. Any class that wishes to implement an interface must have certain behaviors in the form of methods defined by the interface. Now this sounds a bit strange, but we can go over some examples to show exactly how this works. So, interfaces are not like classes. So we can create a sample interface, and already we see a difference. Interfaces in Java are defined by the interface keyword, where a normal class would have class, an interface instead has interface. So, what goes inside of an interface? As of Java 7, interfaces mostly just have abstract methods in them. Now, abstract methods are simply method signatures with no actual content in them. So, this interface demo interface will simply just be a list. It'll be a very simple list that has some ways to get some values out of them. So, what kind of methods should we have in our list interface? Well, first of all, we're going to need a way to add things to the list. So, we'll create an add method. For the sake of simplicity, our list will only hold integers. So, we'll have a way to add an integer to our list interface. Let us also be able to get the maximum value and a way to get the average. Again, just as a simplicity matter, we'll return the average as an int, even though it may be more appropriate to return it as a double. And finally, just to show that these methods can have just about any type of signature, let's have a method that has no parameters and has a void return type. Clear list. This method will just simply get rid of everything in the list. Very basic, not very useful in real life, but this should give us a good idea of how interfaces work. So, an interface by itself won't do us much good. The power of interfaces come from the classes that implement the interface. So, working in Eclipse, there are a couple of ways to do this. So, for our first implementing class, we'll do an array-based list. So, in Eclipse, we can actually define interfaces to be implemented while we are creating our class. So let us search for the interface we just created. And when we hit finish, we will already have method stubs for the methods that are defined by the interface. Now, when a class chooses to implement an interface, it must have all of the abstract methods defined in the interface. So, add, getMax, getAverage, and clearList. All four of those must be in any class that wishes to implement interface demo. When Eclipse makes a class implement an interface, it will add all methods that are required by the interface that are not already in your class as method stubs. Method stubs are simply one-line method that returns 0 or false or null that will allow your code to compile, but obviously it probably will not work properly. So we need to actually implement these. So one thing to note is that interfaces do not have constructors in them. So your object that implements the interface must still have a constructor. And in addition, you will probably want some fields in your object. There's no restrictions on this in terms of interfaces, so we're going to want our actual array. And a size. So we will instantiate these. So in order to implement an interface, the interface actually does not care what we do in the method. It only says that we have to have this method with this parameter with this return type. I could leave this as is, just leave it blank. It will not work as expected, but as far as the interface is concerned, I have the method and it compiles, so it's fine. So while this seems like a bad thing that the interface doesn't actually care what's in it, this is actually a very important part about interfaces, that you can have a bunch of different classes that do work in completely different ways, but as long as they all have the same result and they all implement the same interface, they can actually be treated very similarly, even though they do the work in different ways. So I'll just start. Again, very quick and dirty. Basically, we'll just try to add the new element to the array. If it's full, then we'll just throw an exception. Again, this is kind of dangerous, but we're just trying to keep this example simple for now. So get max. So let us just do I guess a basic algorithm for finding a max value. So, for average, I wanted to show that even though, in order to implement an interface, a class must have certain methods, it must have the interface's methods, it doesn't have to have just the interface's methods. It can have other methods too. So, to show this, I'll create a simple helper method for getAverage. We'll call it like getSum. We'll get the sum, and then we'll just divide it for getAverage. Very simple little method. And for getAverage, we'll simply call this method and divide it by size. And then for clearList, we'll just go over the array. And just zero everything out. Okay, so we have our implementing class, this array implementer. It's an array-backed simple list that implements our interface. So we have all of our methods. Now let us actually test it. So I will just create a simple class. This class will have a main method. Let us try to create a variable for our interface demo. Now, if I were to just create an instance of the interface demo, we will find out that we cannot. We cannot instantiate type interface demo because interface demo is an interface. It doesn't know what to do if we try to directly call it. There's no constructor, and the methods don't actually do anything. So we can't directly call the interface as if it were an object. But we can create an instance of any class that implements the interface, even though the variable type is the interface. The actual object can be anything that implements it. Let's just give it a sample size of like 10. So we have this array implementer object that is defined by this interface demo variable. And we can call any method that's in the interface. We'll just add just some numbers. So let's just do a little print statement to show that our thing does work. So we're calling two methods that are defined in the interface, getMax and getAverage. Now let's try to run it. Okay, so it looks like it works. Our highest value is 8. Our average is not exactly 5, but it rounds down to 5 because, remember, average actually returns an integer. So it seems to work. But if we look at the code for array implementer, we can see that although adding to this list is relatively fast, it's just an array lookup, O1 access. Notice that we do have a hard limit on how many things that we can add to this list, and in addition to that, although add is relatively fast, getMax is really slow. Every time we want to find the max, we need to iterate through the whole array and find whatever value is the highest, an O of n operation. So, even though we haven't actually done much here, imagine if we had made a massive program using our array implementer, and we realized that we need to get them. We don't add a whole lot of stuff to the array, but we get the max plenty of times, and we needed to be able to do it fast because it happens a lot. Now, instead of having to go and create a new class and replace every single instance of that class with the new one, because we're using interfaces, we can just create a different class that implements the same interface. So let's just call it sorted implementer. And notice that I didn't actually implement the interface right away, not through the window. You can still implement an interface after the fact by using the keyword implements and then the name of the interface. Now Eclipse and Java C, if you were to try to compile this, would immediately complain and say there's a bunch of methods that need to be in this class that aren't. So we can just add the unimplemented methods, and it will create stubs for all the methods. If you were to do this in Notepad or whatever, you would actually have to type out all of these methods, but you would get the same result. So let us use a collection, a list, to back this up, since sorting with those are a bit easier. Also notice that the constructor for this class does not have any parameters, while the constructor for the array implementer did have one. There's no limitation to what the constructors could be, or no limitation to what any method that is not defined in the interface that gets some method in array implementer. This could be anything. This could be a bunch of different methods with a bunch of different stuff. It's not defined by the interface. The interface does not care about it. Same with constructors. Constructors are not in the interface, so the interface does not care what the format of your constructor is. But because this computer is actually using an older version of Java, I still have to manually type in the type. So let us import array list and list. So now we have our array list. And now we have to do different things. Adding to an array list is different than adding to an array. So we have to do different things in these methods, which is part of the beauty of interfaces, that it doesn't care what is inside the method as long as we do it. So because this is called sorted implementer, we want to make sure that the data is sorted as we add it. Now, there are obviously better ways to do it than the way I'm about to do. We're just going to sort the list every time we add something. This is horribly inefficient, but it'll actually just make my point even stronger, that different implementations can have differences in runtimes in certain situations, and you can very easily switch between different implemented classes of interfaces depending on the situation. So we'll just make the add really slow just by running a sort every time we add something. But because the list is sorted every time we add something, we know the maximum value is. Return list.get. The last thing on the list is the greatest. Average is going to be computed very similarly. It's going to be computed very similarly to how we did it in the array implementer, but we're not going to make a whole method for it this time. And clear list, there's actually a method in array list that does this. So it's just a one-line method. Okay, so we have our array implementer and our sorted implementer. So what if I wanted to drop the array implementer and use a sorted implementer instead? If they were two completely independent classes, it could be a fair amount of work. But because I'm using interfaces, I don't even need to change the type of I can just make its object different. And if we look at the results, behaves just the same. So what about this little method, this getSum method in array implementer? It wasn't defined by the It was not defined in the interface. So can I call it? So I.getSum. Well, as we see, it throws an error because interface demo does not have a getSum method in it, and we are assuming that I is an interface demo. Now there is a way we can still run it, and that's through casting. We can cast objects to be other objects. So if we do this cast, we will assume that I is actually an array implementer. And in this case, because I actually is an array implementer, it works. So the sum of all this stuff in here is 16. However, what happens if our assumption that I is an array implementer is wrong? Well, we will throw an exception, a class cast exception, because first of all, sorted implementer is not array implementer, and second of all, sorted implementer does not have a getSum method, so it wouldn't even know what to do. So this is why doing this casting business is very risky, because if I actually had this in the code, I wouldn't really be much better off by using interfaces if the code depended on one particular implementing class being the interface. So, just as a quick show that these interfaces actually do stuff differently, I previously have written a simple class that will time how long some of these operations takes. So I'm comparing array implementer versus sorted implementer. We'll run 20,000 trials of add, max, and average. Now we already see array implementer is very fast addition, very slow maximum, similarly slow in getting average. We see that sorted implementer is incredibly slow with additions, but it's get max. It can do 20,000 get max calls in about 2 milliseconds. So we see that both of these two different implementations have different advantages. If you want to add a whole bunch of stuff to a list and you don't really need to get the stats of it very often, the array implementer is the way to go. Super fast addition, but it's pretty slow at everything else. The sorted implementer, on the other hand, if you have a relatively small list that you need to get the maximum or the average of a lot, this would be better, because although the addition is very slow, n log n addition versus array implementers O of 1, but sorted implementers get max is O of 1, while array implementers is O of n. So you see that they both have different advantages. We can make a whole bunch more implementer classes that have different advantages, and we can just swap them out in different situations with minimal impact on our code. We would have to refactor the code very little in order to accommodate this. So this shows the real power of interfaces, that they can allow our code to be much more recyclable, more adaptable, a lot neater. In general, makes things easier to read and easier to debug.